Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you Cartesian product in relational algebra. So let's begin. Once again, the database that we will be using is the sample database for a university. It contains 3 tables. The first table is the instructor table, which tells you the ID of instructor, the names of instructors, the departments, and salaries of these instructors. And the second table we have is the course table, which shows you the ID of the course, the names of all the courses, the semesters in which they were taught, and the year in which they were taught. And then we have the teachers table. The teachers table tells you the relation between instructor and course. So if you look at one of the rows of teachers table, for example, the last row shows you 4 with 1. And so you can go to instructor table and find out who is having the ID 4, and you'll know it is Mary. And across that, 1 is written. So you can go to course table and check what is 1, and 1 is DBMS. So with this, you can conclude that Mary taught DBMS in odd 2019. This is how we have created a simple university sample database. And using this, we are going to do Cartesian product. So Cartesian product is another fundamental operation in relational algebra, just like union and set difference, and also select and reject. This is also a binary operation, just like union and set difference. So it requires 2 tables in order to work. And we use a Cartesian product when we want to combine 2 tables together. So when we require some data that cannot be fetched from just one table, then we use a Cartesian product and combine 2 tables. And here, each row of one table will get combined with all the rows of the second table. That's how the combination works, and you'll understand it better with an example. But if you talk about this in mathematics, and if you're given set A and B, and A contains 1 and 2, and B contains 2 and 3, then the Cartesian product will be combination of A and B, such that you get 1, 2, 1, 3, 2, 2, and 2, 3, which is combination of both the sets. So that's how Cartesian product works in practice in mathematics with numbers. And we are going to see how it works with tables. So we're going to find out some useful information using Cartesian product. Now consider only 2 tables, which are instructor and teachers. Just using these 2 tables, we are going to see what Cartesian product is. So if I do something like this, if I do instructor cross teachers, then this is a Cartesian product. And what that gives me is a combination of each row of instructor with each row of teachers. So if you go back there and see, there are 4 rows in instructor and 3 rows in teachers, which means it's going to return to me 12 rows, because 4 here and 3 there, that gives me 4 times 3, which is 12. And so I'm having 12 rows. You can see that here, the first row of teachers, which is 1, 2, is combined with all 4 rows of instructor. And then the next row of teachers is again combined with all 4 rows of instructor, and so on. And notice the number of columns. The number of columns are going to be equal to the total columns of both tables. So the first table has 4 columns, the second table has 2. So the total is going to be 6, and that's what I am getting in this table. I'm getting totally 6 columns, as you can see here. And so this is the Cartesian product. And as such, right now it does not make any sense to us when we combine these tables, because how does that help you? It does not give you any useful information. It's just a bunch of gibberish where just two tables are getting combined. But then if you look at it closely, you'll be able to see that there is some information that you're getting here, which is you can compare this instructor's ID, which is from the teacher's table, with that instructor's ID, which is from the instructor table. And once you do that, you will get some useful information. You will know which instructor is teaching which course. Of course, you'll only get the ID of the course, but you will still get it. So whenever the ID of instructor matches, you can say that that instructor is teaching this particular course ID. So if I remove instructors with only the IDs that match, then there are only three instructors, 1, 2, and 4, which will be left because those are the only ones matching, and also because the teachers table contained only 3 rows. So this is what you will end up getting. And now if you want to get from here only names of instructors and the IDs of the courses they teach, then this is how you will be writing your query. So first of all, you have done instructor cross teaches in one bracket. On that, you have applied the condition of matching the ID of instructor with the ID of teaches, instructor ID of teaches. And if both are matching, you fetch that row, and then you apply the pie condition and fetch one column from it. So this is how your query looks like. And in this query, you can notice how I have written the name of the table and then the name of the column in mentioning the condition. The reason for this is because both the column names are same. Both are I underscore ID. So I cannot write I underscore ID equal to I underscore ID. That would be ambiguous. So I have to write the name of the table that I'm referring to out of these two tables, the combination of these two. And so I have written instructor.I underscore ID equal to teachers.I underscore ID. And once I get that, then I can simply fetch whatever I need from there, which is I name and CID, and that's what I will get as a result, only names and IDs of courses. So this is how you can make use of Cartesian product to fetch some meaningful information. Let's go a little bit deeper into it. Consider doing a cross product of this entire query that we wrote earlier with course. So this was the table you see on the left hand side. That's the table that we saw earlier. That's what we got as a result of our query. And now we are taking a cross product of that with course. So obviously what we are going to get is, again, there are 4 rows here, 3 there. So we are going to get 12 rows and totally 6 columns. And that's what you're getting here. There are 12 rows with 6 different columns. And once again, now if I want some useful information, I can compare the common columns, which are CID in both the tables. And once I do that, once I compare those, then this is what I will get. I have C underscore ID coming twice, and you can see both are matching. So at this point, if you like, you could remove one of the columns because both are having the same information. Now from this, yes, you can get rid of one of the columns since both display the same information, so it doesn't matter if you remove one. And then you can also further simplify your query. This query is all right, but there are too many brackets, and to understand it, you'd have to go inside the query and look at it closely. But if you want, you can change it and write it in a little bit better manner. So right now, first, we are just fetching the names and the names of instructors and the courses that they taught. And after doing that, now I'm going to show you how to write this same query in a little bit different way. So This is how you can do it. This is the query we wrote earlier. This is a simpler query, but it does the same work. So it is also known as an equivalent query. A query that produces the same output as another query, but is written in a different manner, is known as an equivalent query. So this query is fairly simple because within the brackets, I have first taken a Cartesian product between instructor, teachers, and course. And then after taking the Cartesian product, I have applied to it the pi operation. So the pi operation and the sigma operation. And you can notice here how the conditions have been combined. You can see that instructor ID and ID from teachers is compared, so it is matched. And the second condition which we applied is also added here. And here I have written teachers C underscore ID equal to course C underscore ID. And that would satisfy, that would take care of all the conditions that we need. We want to match ID of instructor with ID given in teachers. And we also want to match the ID of the course with the ID given, course ID given in teachers. So we are doing that. And then we can apply the pi condition and select only names of instructors and names of courses. So this is how you can simplify your query to make it look better. So when you do this, you can see already there's a considerable decrease in the number of brackets used here. There are only 4 here, 2 closing and 2 opening brackets, whereas that side we had 3. So if you want to write your query in a better manner, you can do this. So, and a little bit of a tip is whenever you have any questions in relational algebra to do a Cartesian product, or when the question requires you to combine 2 tables, you can straight away apply a Cartesian product and an equal to condition. And it's not necessary that you need to do equal to, you could do greater than, less than, any kind of operation that you want to do with sigma. So that's how you can use Cartesian product. And that's it for this video. I'll see you in the next one. Thank you for watching.